Hello everyone. This is an extension of our discussion on the compounds containing polyatomic ions. So we will discuss how to write their chemical formulas as well as their names. Okay, so I have here a prepared list of cations which are more on the different elements. So you have here sodium, magnesium, calcium 2 plus, then Cr3 plus and Fe2 plus. We also have here the ammonium ion, which is a polyatomic cation. Now on the right side, we have the anions, the polyatomic anions. So if you refer to your list, you will know the names of these anions. So this is your nitrate ion, the hydroxide, carbonate, sulfate, chromate, and their phosphate ion. You also have the charges or the oxidation numbers highlighted in different colors so that it will be easier for you to follow later on where the superscripts go and where the and how it will appear in the chemical formula. All right, so in getting the resulting ionic compound, all we needed to do is to do the crisscross, disregard the sign. So for example, in here between sodium and the nitrate ion, so we just transfer the signs, cross, disregard the sign. So in this example, sodium here has a subscript of 1, Na1, and then NO3, right? So since we do not have we have 1 as a superscript. Once it becomes a subscript, this should be like this, okay? But since it's 1, we need not write anymore. So we can actually erase the subscript 1. Now let's take a look at magnesium hydroxide. So when you crisscross, the charge of the magnesium ion becomes the superscript or the subscript of hydroxide. So Mg, 1 here transfers to Mg, the 2 plus transfer to the hydroxide ion. So it's supposedly OH, then since it's for the whole group, then we enclose it with 2. Alright, so the 2 plus charge from magnesium transfers to be the subscript of the hydroxide ion. That's why you have magnesium hydroxide. Alright, so this is now where your charge goes. Okay, now sir, what about the 1 from hydroxide? Again, we do not reflect it anymore because just like in algebra, we usually don't write 1, okay, as a coefficient. Now try this calcium and then carbonate, Ca2 plus and CO3 2 minus. Okay, so what happens in here? So if you crisscross and disregard the sign, then you end up with Ca. Supposedly you will have 2 here, and then CO3 as a group will have 2. But since they are of the same value for the subscript, we reduce them into 1. So let me write it to be complete. So this is 2 supposedly, but we get to cancel them. Alright, such that we will just end up with Ca, okay, CO3. CaCO3. Remember that for ionic compounds, we report them in the smallest whole number ratios. They are empirical formulas. Okay, that only works for ionic. If it's for covalent, then we have to report the molecular formulas, right? This one. The next 2 examples are multivalent ions or multivalent atoms, meaning they are atoms that have variable charges. Alright, so for example, chromium and iron, they belong to the D block, so they usually have the charge plus 2 or plus 3, plus 4 for chromium, plus 6 even, and then iron can exist as plus 2 and plus 3. Okay, so these are atoms with variable charges. So we apply the same principle in writing their chemical formula. So we just have to do the crisscross, disregard the sign. So the 3 plus of chromium transfers to the sulfate ion group. Okay, but since it's for the whole group, then we must enclose it in a parenthesis. and the 2 here transfers to the subscript as a subscript of chromium, right? So we end up with Cr, and then let me just write it down. Sulfate here, CrSO4, and we know that there is a subscript that's for the whole group, so we end up with green Ca, CrS2 here from the sulfate ion, and the 3 is from chromium in here. Alright, so CrSO4 sub 3, and again the 3 is for the whole group. Okay, that also serves to separate the subscripts. Alright, now try this one, Fe2 plus and CrO4 2 minus. So the same thing that happened with calcium and the carbonate ion here, since they are the same, then we can just cancel them out. So we end up with Fe CrO4. Alright, FeCrO4, because we have we can cancel 2. Now the last one is ammonium and a reaction with the phosphate ion. So in here we have NH4, okay, and then the 3 becomes the subscript of the phosphate ion. However, it's for the whole group, so we enclose the 3 becomes a subscript of the ammonium ion. Now it's for the whole group, so we enclose it in a parenthesis. That's 3 subscript 3, and then PO4. Since the superscript of the ammonium ion is just 1, so when you transfer it here, then there's no need to write 1 anymore. Alright, so let's go to the naming. The first 3 elements are representative elements, so they have fixed charges. So whatever, we don't need to indicate their charge. So for example, in here, let me just clear this one out. You have, it's made up of the sodium and the nitrate ion, so we name that as our sodium nitrate, NaNO3. Okay, in the second example, that is a product of magnesium and the hydroxide ion, so that's magnesium hydroxide. Right, so in naming compounds with polyatomic ions, you just give the name of the cation and the name of the polyatomic anion. In here you have calcium carbonate. In this case, since chromium and iron have variable states or variable charges, then we must really indicate their charge. All right, so the 3 comes from chromium, okay, as shown in here. Therefore we must say chromium 3 sulfate, because this is our sulfate ion. Chromium 3 sulfate. So in here we have iron 2, then chromate, iron 2 chromate. And then in this example we have ammonium phosphate. All right, ammonium phosphate. So that's it. If you have any more questions, we can deal with more examples later on. Alright, so those are compounds containing polyatomic ions.